We've got 4 examples we're going to run through here, and they're all examples where we're going to use the exponent properties that we've learned to solve different equations. So this first example, we've got x to the 2/3 equals 64. And what I want eventually is I want to get x equals something. So right now it's x to the 2/3, and there's a way that I can get rid of that 2/3 power. And using the power of a power rule, if I do to the 3/2 power, when I do 2/3 times 3/2, that's going to give me just 1. And so one of the rules we learned is if you take a power to a power, you end up multiplying those exponents. So we're going to take it to the reciprocal exponent. And with all of these, I'd encourage you to, write them down, try it yourself. I got a little bit ahead of myself on this one. But try them, see if you can do them without my help, and then if you can't, just follow along and see how I do. So now we end up with just x over here. And we get 64 to the 3/2 power, to the 3/2 power. And so what this is it's the square root. That 2 tells me the root is 2. And then we have 64 to the 3rd. So what we can do is do the square root of 64, which is just 8. And so we get 8 to the 3rd, which is 512. Cool. So that's just 512. 512 to the 2/3 is going to be 64. All right. So next example, we'll slide over here to the right. If we have 3x to the 4th plus 7 equals 250, my first step is I want to get this x thing all by itself. And so what I'm going to do first is I'm going to subtract 7. I get 3x to the 4th equals 243. And then once again, I want to get the x thing by itself, so I'm going to divide by 3. It might be tempting to want to do the 4th root here, but that 3 out in front is kind of messing things up. So I'm going to divide by 3, and I get 243 divided by 3 is 81. And you could just use a calculator if you're not sure on that one. And then if I have x to the 4th, to cancel out the 4th power, I can do the 4th root. Or another way is if you have x to the 4th, you could do to the 1/4 power. These are saying the identical same thing, just writing it differently. So the 4th root of 81, or the 1/4 power of 81, is just 3. All right, so moral of the story is we want to undo all of the operations so that we get just down to x. And you start by getting rid of any adding or subtracting, and then we undid the multiplying, and then we get rid of that exponent. Okay, so we've got 2 more to finish up on. They're a little bit more challenging than the first 2. And so this next, the third example here is 7x to the 3/4 plus 2 equals 191. So I'm going to start by subtracting 2. I get 7x to the 3/4 equals 189. And then I'm going to divide by 7. And I get x to the 3/4 equals, I don't expect you to know this off the top of your head, but this is 27. Right, yep, I'm just verifying in my head. Yep, that's 27. And so then just like on the last one, I want to get rid of this 3/4 power. And so I can take both sides to the 4/3 power. Actually, this is like the first example. To the 4/3 power. And that makes this just x. And then this ends up being the cube root of 27 to the 4th. So the cube root of 27 is 3. And 3 to the 4th is 81. So this one would just be 81. All right, and then the last example, we've got 9x to the negative 2/3 equals 16. So this one I think is going to be the most challenging of the bunch. We do not have any adding or subtracting we need to get rid of, so we're going to start by just dividing by 9. And we get x to the negative 2/3 equals 16 over 9. And that ends up giving us, let's see, it'd be 1.7 repeating. So it's not a really nice fraction. It doesn't get us down to a nice number. But what I do notice is that both 16 and 9 are perfect squares. So I'm just going to leave it like this as a fraction, and hopefully something will kind of cancel out here. I don't need that negative 2/3 in parentheses. In fact, it's just going to make things a little muddier. So what we're going to do is, just like on the other ones, if we have something to a fraction exponent, we're going to take the reciprocal power. So negative 3 over 2 power. All right, so then this just becomes x, but then we have to figure out, how do we handle this negative 3 over 2 power? Well, it's going to be the square root of 16 over 9 to the negative 3 power. And the square root of 16 over 9, we can do the square root of each of those pieces. And so that's going to be 4 over 3 to the negative 3 power. Now, another exponent rule we learned is that this negative 3 power affects both of the parts of the fraction. And so this ends up being 4 to the negative 3 over 3 to the negative 3. And then another exponent rule we learned is, if you have a negative exponent, you just take and flip it to the top, or if it's in the top, you flip it to the bottom, only if it's a negative exponent. And so this ends up being x equals 3 to the third over 4 to the third. And then we can just evaluate these. 3 to the third is 27. 4 to the third is 64. So all of that, and we get 27/64. And then this doesn't reduce at all. That's in its simplest term, so that's it. So there's 4 examples of solving equations using exponents, using the exponent properties. You might run into some a little bit more challenging, but these should kind of give you some skills to get through most of them.